So we're ready to look at the x squared function. If we want to find the graph of y equals x squared, and I have set up my table already for you. I've got these x's that I'm going to be putting into my function. You might be asking, how do I know what needs to go in for x? Well, most of these, if there's anything, any kind of, you might say action, if there's anything happening that changes the graph, most of the time it generally will be happening right around the origin here. So most of the time I try to put in a couple of values that are smaller than 0, a couple of values that are bigger than 0, just so that I can see what's happening to the graph whenever it makes any kind of changes. So I'm going to let you pause the video. You should be able to do this yourself. I want you to substitute each of these numbers into your function and fill in your y column. And then plot the point, either plot the points by hand or look at it on your calculator, and go ahead and fill in this graph. And then we'll talk about the domain and the range. Okay, so you should have gotten for your y values positive 4, positive 1, 0, 1, positive 4. So we're going to take each of these ordered pairs and locate them on our graph. Negative 2 on x and positive 4 on y is going to put me about right here. Negative 1 on x, positive 1 on y puts me here. And then I've got a point at the origin. I've got ordered pair 1, 1 and ordered pair 2, 4. Now look carefully at your graph before you go to connect your dots. This is not going to create straight lines. We talked a little bit before about how the exponent gives us some information about our graph. If we had y equals x to the first power, we would expect to see straight lines somewhere, or at least straight segments. With this having an x squared, I'm expecting it to look like some type of curve. As a matter of fact, it's a quadratic, so it's actually going to be a parabola. All right, so with that information, when I go to connect the dots, I need to take into account what type of graph am I expecting to see. And this is going to be a curved shape. And we get this parabola that's centered at the origin, and it opens up. Okay? What about the domain? Well, the domain would be, you can think of this looking at it as an equation or looking at it as a graph. The domain would be the possible x values that would give you a legitimate value back. So just looking at it here, you could probably see that you could put anything in here that you want for x, and it's still going to give you a y value. Looking at it graphically, we're looking along the x-axis. As we move from the left side of the graph to the right side of the graph, what x values will be included in this graph? Well, if you look at the ends, we've got these arrows, and they indicate that it goes forever, and it goes up forever, and it gradually will spread out in both directions forever. So as I'm moving in from the left side, my beginning point on my graph would be at negative infinity, and it's going to continue all the way out to positive infinity. So my domain, I could say it's all real numbers, or I could say it's negative infinity, comma positive infinity. For my range, I'm looking at all possible y values. So again, you can look at it this way with the graph. Just think about what happens if you start putting in numbers for x and squaring them. What kind of answers are you going to be getting back? Well, if you square it, you're only going to get positive answers back. Looking at it graphically, you're interested in what's occurring along the y-axis. So you're going to start at the very bottom at the smallest possible value for y you can start with and move up, and you're looking for when the graph actually begins. The graph actually of this x squared function begins right here at the origin. So that's going to be the smallest y value. And then it's going to go up to positive infinity. So we can say that our range is going to be square bracket, 0, comma, positive infinity. Example 2, we're looking at the square root function. So we've got y equals square root x. Again, we generally expect any changes in the graph to occur around the origin, so we're still starting out with these same x values, If something doesn't work, then we'll just throw it out and we'll look for something else that might. So go ahead and pause the video, substitute these x's in, see what you get back. If you have some that don't work, then think about what else might work. So take a moment to do that and see if you can come up with an idea for what you think the graph might look like. Okay, so the first thing you might have noticed is that when you put in a negative x, when you put in negative 2, you're trying to find the square root of negative 2. All right? We are not going to try to graph complex numbers. We're going to stick with the real numbers here. So in this case, when you put in your negative 2 and try to take the square root, you're not going to get a legitimate value back that you can work with. So the negative 2, we're just going to eliminate the negative 2. Same thing with the negative 1. If we try to take the square root of negative 1, we're getting a complex number, and we're not going to graph a complex number. So we can eliminate those two possible x's. They're not giving us y values back that we can graph. If we put 0 in for x, you should have gotten 0. Square root of 0 is 0. If you put in 1 for x, you should have 1. If you put in 2, you're going to get a decimal, and that's fine. It will be approximately 1.4. Okay? But to make it a little bit easier to graph, maybe we should put in a number that's a little bit easier to work with. What's a nice number that I could put in for x? Well, a perfect square would be 4. So let's put in 4 for x, and then that's going to give me a 2 back. I like that a little bit better. So I've got ordered pair 0, 0, 1, 1. I could graph 2, approximately 1.4, and then I can also use order pair 4, 2. So 0, 0, 1, 1, 4, 2. Again, before you connect your dots, think about what you've got here. Now, I haven't really told you anything about what to expect. If you've got, this would be x to the 1/2 power. Okay, so that's going to be, I haven't told you anything about what to expect there. But it is going to be a curve. You're going to start at the origin, and then you're going to draw a curved shape through these dots, and it will go out to positive infinity like this. So this is what your graph should look like. Really, it looks like if you were to take that parabola that you got from the x squared function, lie it on its side, and then chop it in half and only take the top half of it, then you would have a graph that looks like the square root function. What about the domain? What do you think the domain is going to be? Well, as we move in from the left side of this, looking at the x values, the graph does not even begin until we get to the origin. So x equals 0 is going to be my starting point, and it goes out to positive infinity. So my domain, I would use a square bracket, 0, comma, infinity. For my range, y values, I'm going to go to the bottom and go up. My graph begins at the origin, so from y equals 0, and it goes up forever to positive infinity. So my range in interval notation would be square bracket, 0, comma, infinity. This time we want to graph the function y equals x cubed. Again, you can substitute these values in for x, fill in your y column. Maybe they'll work, maybe they won't. I'll let you decide. And then see if you can come up with what you think, at least plot your points. Maybe wait for me before you connect your dots so we can talk about what kind of an image we should be seeing in our graph. But go ahead and take a moment and fill in your table and try to graph your points that you plotted on the try to plot your ordered pairs that you get from your table. So in your table, your y values, you should have -8, -1, 0, 1, +8. Now let's plot those points. Okay, so your points should look very similar to mine. And it should be something where you should be able to kind of connect it with this like swoosh movement here. So really what you have with the x cubed function, one side of it, on the right side of the y-axis, looks like half of a parabola that opens up. And then on the left side of it, it looks like half of a parabola that opens down. Okay, so this is your x cubed function. It gradually spreads out just like the x squared function did. So for our domain would be negative infinity to positive infinity. Our range goes from negative infinity to positive infinity on the y's. Okay. Function 4 is the cube root function. Y equals the cube root of x. Again, I would like you to fill in your table and plot the ordered pairs that you find. And then we'll talk about how to draw your graph. So go ahead, pause the video, do your table, and plot your points. Okay, so this time, when you put in -2, you probably you should have gotten a decimal. If you don't want to graph the decimal, that's fine. Let's think about a number that we could put in for x that would give us a whole number back that we didn't have to round. If you're doing a cube root, what's a good number to put in here for your x? What if we put in a -8? Because 8's a perfect cube. And then let's put in a +8 down here. Again, you don't have to put in these numbers. If you put in the numbers that I had originally and use the decimals, that's fine too. If I put in -8 for x, I'm going to get -2. And then I'm going to have -1, 0, 1, +2. So let's plot those points. Alright, so you should have something similar to mine. If you did the -2 for x and graphed the decimal, you probably did not get a very good enough of a picture to know how to graph it, because in the middle they're just lining up. And if you put in -2 and got a decimal, then you will probably right around here somewhere. So the -8 and the +8 for x give us a little bit better idea of how to draw our graph. Alright, what does this look like? Does it look similar to something you've already seen? If you go back and look at the graph that you just did for the x cubed function, it was this S sort of shape. And this time we have the same thing happening, but instead of it being this way, now it looks like it's kind of wrapping around the x-axis. So you've got what looks like half of a parabola on its side, and then the other half under the x-axis like this. So that's what your cube root function should look like. What is our domain? We're going from negative infinity to positive infinity along the x-axis. What about our range? What do you think it should be? Starting at the bottom of the graph begins here, but it's got an arrow, so that means that as it goes out, it also gradually spreads up and down. So it's going to start at negative infinity on the y-axis, and it's going to go up to positive infinity on the y-axis. So our range and our domain and our range are both all real numbers for the cube root function. So again, you need to kind of commit this to memory. Cube root function is this kind of S-looking shape that's long and flat around the x-axis. So before we talk about function 5, the semicircles, just want to kind of remind you that from high school we have this equation of a circle, which we know is a circle centered at the origin has the equation x squared plus y squared equals r squared, where r is your radius. We're not really that interested in graphs of circles, though. I don't know. I'll let you think about why for a moment. I don't really want to tell you yet. But if you think about what we're working with in this chapter in general, and think about a circle, why would it not be as pertinent to us as some of the other things we've been talking about? All right, we'll talk about that in a moment. But knowing that the equation of a circle is x squared plus y squared equal r squared, if we were to solve this for y, we would get the equation of a semicircle. The equation of a semicircle would be this y equals plus or minus the square root of r squared minus x squared. Okay? So with this knowledge, we can now talk about how we can graph semicircles. We're not really going to be doing a lot of plotting points for the semicircles. You can if you want to. But if we know that this is centered at the origin and we know how to find our radius, that's really all we need, all that we need in order to graph this. So let's move on to number 5. All right, we are asked to graph the equation y equals negative square root of 4 minus x squared. Again, feel free to use a graphing calculator to help you out with this as well. All right, just looking at this, I know that it's centered at the origin, and I know that my radius would be the square root of my constant, so the square root of 4, so r is 2. So I just need to go to the center, go to the origin here, and I want to use my radius of 2. So I can go out here and here, 2 spaces. All right, and then also notice that there's a negative in front of this one. If there's a negative in front of it, then you're going to be looking at the bottom underneath the x-axis. So really, whatever y values are coming out of that radical, out of that square root, you're going to negate them and put them down here. So we can, if we have a radius of 2, that means we can come down 2 spaces, and then we can connect these dots with a semicircle. Now that you've got the picture to look at your semicircle, do you have an idea as to why I'm more interested in a semicircle than I am in a circle? Think about it for a moment if you haven't already. But essentially, we're working with functions here. This one, is this a function? And how do I know? Does this pass the vertical line test? Yeah, it does. So this is a function. A circle, on the other hand, is not a function because it doesn't pass the vertical line test. So that's why we're more interested in a semicircle than we are in a circle. All right? So as far as how to graph a semicircle, you just need to understand how you can find your radius. It's going to be the square root of your constant. And then you have to look at the sign in the front. If you don't see a sign in the front, then it's going to be above the x-axis. If you've got a negative in front of it, then it's going to be below the x-axis. What is a domain? All right, this is a little different from the ones that we did earlier. The other ones that we were doing tended to go out to infinity in one direction or the other. This one has a beginning and an end. If we do the domain from left to right, the graph begins when x equals negative 2, and it ends over here when y equals positive 2. So my domain, I can use a square bracket, negative 2 comma positive 2 square bracket. And for my range, so go from the bottom up, it begins here. This will be negative 2 on the y-axis, and it goes up to the origin. So square bracket, negative 2 comma 0.